Ever wondered why your streaming service suggests that weird 80s synth album after you binge a retro horror movie? Or how your phone's camera picks the most diverse set of photos to show you? Behind these decisions is a clever math tool called a Determinantal Point Process, or DPP for short. Today, we're breaking down a game-changing breakthrough that makes DPPs faster, smarter, and more reliable. No jargon, just clear explanations. So what's a DPP? Think of it as a mathematical way to model diversity in data. Imagine you're curating a playlist. You don't want all the songs to sound the same, right? A DPP helps ensure variety by mathematically balancing how similar or different items are. But here's the catch. DPPs rely on something called a correlation kernel matrix, a grid of numbers that describes how every pair of items relates. The problem? Estimating this matrix from real-world data has always been a mess. Traditional methods, like maximum likelihood estimation, are like trying to solve a puzzle with missing pieces and shifting parts. The math gets wildly complicated, and the results are super sensitive to tiny changes. It's like trying to bake a cake with a recipe that keeps rewriting itself. But here's the twist. Researchers just cracked this code with a simple, closed-form estimator. Instead of wrestling with that chaotic likelihood function, they found a shortcut using principal minors, which are just smaller chunks of the bigger matrix. It's like figuring out a recipe by tasting a few ingredients instead of the whole dish. And here's the kicker. This estimator isn't just easy to use. It's mathematically bulletproof. The team proved it's consistent, gets more accurate with more data, and asymptotically normal, follows a predictable pattern as data grows. Even better, it's robust to errors, like a GPS that still works if your phone's a little out of sync. Why does this matter? DPPs are everywhere. They power recommendation systems, help AI choose the most informative images, and even model how neurons fire in the brain. With this new method, we can build better models for everything from personalized ads to understanding complex biological systems. So next time you get a strange recommendation, remember, it's not magic. It's math. And thanks to this breakthrough, the next generation of DPPs might just be smarter, quicker, and a whole lot more accurate. Thanks for watching, stay curious, and keep exploring the numbers behind the magic.